Example 2. It looks very long. It's okay. Nothing's going to happen. It's fine. All we have to do is read it. It says, at some point, all laboratory chemists learned the same hard lesson. Hot glass looks just like cold glass. Carla Barraza, she's a friend of mine, she is a chemist, is a somewhat clueless chemist who picked up a hot beaker someone left on her bench. At the moment Carla grabbed the 140 degrees Celsius glass beaker, 567 joules of heat flowed out of the beaker and into her hand. Ouch. If the beaker was 137 degrees Celsius, the instant Carla dropped it, what is the collective mass of the shards of beaker now littering the lab floor? Heat capacity of glass is 0.84 joules per gram times degrees Celsius. Okay, start with the given. Given. We look for numbers. First number that we see, 140 degrees Celsius. Okay? I was looking at this 7 over here. We need to know which temperature that is. It's usually the initial, if it's listed first on the exercise. Sometimes it's not, but in this case it is, because it's at the instant or moment Carla grabbed the beaker. So temperature initial, (140 degrees Celsius). I know we have 567 joules, but it's good practice to write the temperature final after the temperature initial. So let's write temperature final, and that is, yes, 137 degrees Celsius. That's when she dropped it. So now we can look at the 567 joules. Remember, the units, they tell you what variable you're going to write. So joules is for heat energy. Heat is Q. So we write Q. 567 joules. Oh, let me redo that J. And then we have the specific heat capacity. That would be C for capacity, specific heat, 0.84 joules per gram times degrees Celsius. And we're looking for the mass. Look, what is the collective mass? Even though the beaker broke, let's say if we were to sweep it and put it on a scale, we could find the mass. Okay, so M equals question mark. I'm going to show you 2 ways to approach this exercise. One is the algebra method, and the other one is a non-algebra method. I like math, and I believe that's the right way to show it, but it's okay if you don't like it or you think you don't understand it. I'm going to show you a way without algebra. Okay? And that's because if you look at our equation, mass is down here. And we're not looking for heat capacity, we're looking for mass. So what can we do to modify our equation so it's solving for mass? And I'm going to use my whiteboard for the algebra method because I need more space. Let's put this over here. There you go. Okay. So let's write our equation. Let me find the center. Yeah, so this is our equation. C equals Q divided by M times delta T. We want M. We want it to be by itself. So this line represents a division. So we go for the opposite because Q is being divided by the product of M times delta T. So we multiply by the mass on both sides. Don't forget. This M will cancel this M over here. And our equation would look like M times C is equal to Q divided by delta T. Now, these two are being multiplied. That means we need to use the opposite. What's the word I'm looking for? Math operation. There you go. Which is division. So we divide by M. Oh, no. That would give us C. We divide by C, okay? Because we want M by itself. Okay? Both sides. This cancels. And we have mass is equal to Q divided by delta T divided by C. You can use the equation like this, but I don't recommend it. This is not elegant, it's not clean, okay? So let me show you what to do to make it look simpler, because you have a fraction and then it's being divided, so yeah, no. I'm going to use parentheses over here, because this is one fraction. I'm going to make this C into a fraction. So let me move this over here a little bit. Sorry about the reflection. This over here. So I'm going to put my hands. How can I make C into a fraction? If I have C divided by 1, it'll give me C. It won't change anything. So I'm going to divide C by 1. Let me erase this. And then I have two fractions. 1, 2. I'm going to show you the cheeseburger method. Believe it or not, I learned this in college. So the main ingredients for a cheeseburger are the bun, the cheese, patty, and the bun. So we always put the buns in the toaster and patty with cheese on the grill. So these two go together, bun and bun, and then cheese and patty go together. So we're going to multiply them together. So bun multiplies bun, then cheese multiplies patty. Okay? So that would be bun times bun, that is Q times 1. So we're going to have a division sign. So Q times 1. Cheese and patty, that is delta T times C, because it's cheese and patty. So C times delta T. You can also think of it as outside, inside. Okay? Oh, you can't see. There you go. So Q times 1, bun times bun, C times delta T, cheese times patty. Q times 1 is just 1. So mass, let me write it over here. So mass would be Q divided by C times delta T. That's the equation for mass. This is the algebra way. Okay? So don't forget about this equation. Write it down. Mass equals heat divided by heat capacity times delta T. Okay? Let me go back over here. And let's write it down. We said it was mass equals heat divided by C times delta T. Correct? Can show you. You forgot. What if you don't know how to do algebra? What if you don't like cheeseburgers? What if you're a vegan like me? I have this triangle over here. Now, what is the variable which we want? What are we looking for the mass? So what you do is you cover the M and you have Q, C, delta T. Q is on top, as you can see on my equation. Then C, T on the bottom. If they're together, they're being multiplied. If they are on top of each other, they're being divided. So top divided by bottom. If the bottoms are next to each other, they're being multiplied. So from this triangle, you would get this equation. Mass, because I'm covering the M, equals Q's on top divided by these two being multiplied together. And like my professor in college would say, surprise, surprise, you have the same equation. That's if you don't like algebra. Okay? And this works for our general equation, because it was C, let me show you, equals heat divided by mass times delta T, change in temperature. So if we, if we needed C, cover it up, and yeah, Q equals M times delta T. Or if you want to change the temperature, to just cover this one. If I were to ask you for the heat required to change the temperature of an object, you just cover the Q, and then you have, this is the equation which we use for physics. Q is equal to, I say MCAT, but it's MC delta T. Okay? I'm going to have this triangle for you on your assignments test. That way you can just use it if you don't want to do algebra. Now we can substitute. So mass is equal to Q, that is heat, 567 joules. Joules divided by specific heat capacity for glass, which is over here. So that is 0.84 joules per gram times degrees Celsius times change in temperature. That is, we need to get delta T. This one's very simple. Delta T is final minus initial, right? So it would be 137 minus 40. You would get -3, but we're going to use the absolute value, which is just 3, okay? Because we cannot have a negative mass. So we're going to use 3. But the right way would be to say if it lost heat, then this number would be -567. So you have negative over here, so negative and negative cancels. But we're going to use positive just to make it simple. So 3 degrees Celsius. This 3, I got it from 137 minus 40, and then just made it positive. So let's do it over here. That is 567 divided by parentheses 0.84 times 3 close parentheses 225. That would be grams, okay? 225. So let me show you how we get grams. Joules cancels joules. Degrees Celsius counts as degrees Celsius, and we have grams only. So the mass, let me write it here, and let me use red so it stands out. Mass is equal to 225 grams. I don't need the 0.0 because we have 3 significant digits, as you can see, and this is our answer. Practice with this example in the first one. If you have any questions, send me a message through Schoology.